Imagine the toughest job interview on earth. The hiring process, it's brutal. The standards, basically impossible. And if you get the job, you're expected to stick around for a few hundred years. So what kind of superstar candidate are we talking about here? Okay, so the person, or thing, we're looking for has to be completely unshakable. I mean, they've got to withstand crushing pressure, resist constant grinding wear and tear, and just stand strong against whatever nature decides to throw at them. And this is day after day for centuries. Yeah, no sick days, no vacations. So what is this incredibly demanding job? Well, it's literally holding our world together. We're talking about the role of a building stone. You know, the very foundation of our cathedrals, our monuments, our skyscrapers. And the candidate? A simple rock. But, and this is a big but, before any old stone gets this critical job, it has to go through a whole series of really intense qualification tests. All right, first up is the ultimate stress test. And no, we're not talking about tricky behavioral questions here. This is about pure, raw physical pressure. Can our candidate handle, the weight of the world on its shoulders? Let's find out. This is what's known as the compressive strength test. And its purpose is, well, it's pretty simple. We squeeze the stone until it breaks. It's the most direct way to measure its ability to resist being crushed, which, as you can imagine, is a completely non-negotiable skill for any stone that wants to be part of a building. The process itself is both straightforward and honestly pretty brutal. First, a perfectly uniform cube of the stone is cut. Then, that cube is placed inside a super powerful compression machine. And finally, the machine applies the slow, steady, and just immense force until, bam, the stone fails. And right at that moment, we record the exact pressure it took to break it. So what's a passing grade here? I mean, what does it take to get through this round? A good building stone has to withstand over 100 newtons of force on every single square millimeter of its surface. Now, to put that in perspective for you, that's like balancing a small car on something the size of a postage stamp. Yeah, anything less and the candidate is immediately rejected. No second chances, no do-overs. Okay, so our stone is strong. It passed the first test. But is it built to last? The next phase is what I like to call the durability gauntlet. You can think of this as the background check, and it's designed to uncover any of those long-term weaknesses that could cause big problems way down the road. First up in the gauntlet, we see how much water the stone absorbs. You might be wondering, why does this even matter? Well, a thirsty stone, one with a lot of tiny holes in it, can soak up water, and that water can then freeze, expand, and crack the stone from the inside out. It's a really sneaky, hidden weakness that this test is designed to expose. And the method for this is just beautifully simple. We take a perfectly dry sample of the stone and weigh it. Then, we submerge it completely in water for a full 24 hours. Finally, we take it out, give it a quick wipe down, and weigh it again. The difference between those two weights tells us exactly how much water it soaked up. And the results here are really crystal clear. A stone that absorbs less than 5% of its own weight in water, that's considered excellent. It gets the job. But if it soaks up more than 10%, that's a major red flag. That candidate is out of the running. Simple as that. All right, next up, we test for toughness with something called the attrition test. This basically simulates the constant rubbing, scraping, and friction a stone is going to face, say as a floor tile or a stair step or an exposed wall. It's all about testing its ability to resist being worn down over time. And the difference between a good and a bad candidate here is just stark. A high-quality stone like granite will barely lose any material during this test. That proves it's tough enough for really demanding jobs, like paving stones in a busy square. A softer stone, on the other hand, is going to show significant wear, proving it just can't handle the daily grind. So our candidate is strong and it's tough. But durability isn't just about physical stress, right? What about chemical attacks? In our modern world, one of the biggest threats is acid rain. So how do we test for that? We perform the acid test. It's pretty straightforward. A small drop of diluted acid is placed right on the stone's surface. Now we watch very closely. If we see bubbles or any fizzing, that's a telltale sign that the stone contains calcium carbonate. That's the stuff in limestone and marble. And that makes it vulnerable to being slowly dissolved by acid. A top-tier candidate, something like granite or slate, will show pretty much no reaction at all. Okay, our candidate has survived the physical trials and the chemical trials. Now it's time for the final round, the character check. We need to look deeper to really understand the stone's fundamental nature and its internal structure. We start with a really simple but incredibly revealing scratch test to figure out its hardness. This just tells us how well the surface can resist being marked up or damaged. And to get a standardized result that everyone can agree on, we use a system called the Mohs scale of hardness. So the Mohs scale ranks minerals from 1, which is super soft like talc, all the way up to 10 for a diamond, the hardest thing there is. Just for reference, your fingernail is about a 2.5 on this scale. The crucial point here, the big takeaway, is that a good building stone must have a hardness greater than 3. You shouldn't be able to just scratch it easily. And finally, we look at what's on the inside. Because, strength and hardness are great, but hidden flaws can bring down an entire structure. A microscopic examination is like reading the candidate's entire resume. It reveals its whole history and its internal character. Under the microscope, a geologist is looking for several key things. Are the mineral grains tightly packed and interlocked? Are there any tiny hidden cracks or fissures that could grow over time? Is the overall texture nice and uniform? And are there any soft, unwanted minerals mixed in? A perfect candidate is going to have a clean bill of health on all of these. All right, the tests are over, the results are in. It is time to review the scorecard and make that final hiring decision. Did this stone prove it has what it takes? So the ideal candidate, the one that gets the job, is a true champion. It's exceptionally strong, it's not thirsty, so it has low water absorption, it's tough and hard-wearing, it's chemically stable, enough to pass the acid test, it's hard to scratch, and it's basically flawless on the inside. Only a stone that passes all these tests is deemed worthy. When you think about it that way, it makes every single stone in a great cathedral or an old bridge a kind of quiet hero. Each one is a survivor, a candidate that endured this whole punishing interview process and proved beyond a doubt that it was up to the task of holding our world together. So the next time you walk past an old stone building, take a closer look. You're not just looking at a pile of rocks. You're looking at a carefully selected team of elite experts, and every single one of them aced the toughest job interview on the planet.